Dear students, welcome to physics class. Now we are studying second chapter, equations of motion. Last class we discussed about velocity time graph. Today let us derive equations of motion from a velocity time graph. Equations of motion are applicable only to uniformly accelerated motion. There are three equations of motion. First one, V is equal to U plus AT. Second one, S is equal to UT plus half AT square. Third one, V square is equal to U square plus 2AS. Here, U initial velocity, V final velocity, A acceleration, S displacement, and T time. So, for deriving equations of motion, let us draw a velocity time graph. Here we have to consider the velocity time graph of an object traveling with uniform acceleration. Now let us derive first equation of motion, which is known as velocity time relation. It is V is equal to U plus AT. Here V final velocity, U initial velocity, A acceleration, and T time. Look at the graph. The point P corresponds to initial velocity. Point Q corresponds to final velocity. Look at the graph. When time equal to t1, velocity will be taken as u, and when time reaches to t2, velocity will be taken as v. In this graph, Ps is equal to AR, which is equal to u. QR is equal to v. Now let us see what is SR. SR is the time interval, that is T2 minus T1, which is taken as T. Now let us see all these things. PS is equal to AR, which is equal to U. QR is equal to V. SR is equal to T2 minus T1 is equal to T. From this graph, let us find out acceleration. What is acceleration? Acceleration is change in velocity by time. Acceleration is change in velocity by time. Change in velocity by acceleration A is equal to change in velocity by time. From the graph, change in velocity is AQ. That is, AQ is equal to QR minus AR. Change in velocity is equal to AQ by time interval T. Time interval SR. It is equal to T. This A is equal to AQ is equal to QR minus AR. QR minus AR, and SR is equal to time T. That is V minus U by T. A is equal to V minus U by T. A acceleration, V velocity, U v final velocity, u initial velocity, and t time. Now, after cross multiplying, we have a into t is equal to v minus u. At is equal to v minus u, or v is equal to at plus u, or v is equal to u plus at. This is the first equation of motion. Now let us derive second equation of motion. S is equal to ut plus half at square. This equation shows position-time relation. For deriving this equation, let us consider the velocity-time graph of an object traveling with uniform acceleration. We have studied the displacement of a body within a definite time interval is equal to the area portion under a velocity-time graph. So, to calculate displacement in the time interval S to R, let us find out the area below the graph. Here, the area of the trapezium PQRS is numerically equal to the displacement. Now let us find it out. To find out the displacement in the time interval T1 to T2, it is enough to find out the area of the trapezium PQRS. Area of the trapezium PQRS. We have already studied the displacement of a velocity time graph will be the area below the graph. Here, displacement is the area of the trapezium PQRS. You have already studied the equation to find out area of trapezium. What is the equation for area of trapezium? A is equal to half into h into a plus b. A and B are parallel sides and h is the distance between these two sides. Now compare these terms with our graph. H, it is the distance from S to R, or it is time. P, S is U and QR is V. Now let us substitute all these values. Area for the trapezium, half into SR into A, PS plus QR, half into SR T into U plus V. A is equal to half T into U plus V. From the first equation of motion, we have V is equal to U plus AT. So we can substitute V as V is equal to U plus AT. By substituting the value of V, we have half into T into U plus AT. Look at here, U plus U, 2U. That is half into T into 2U plus AT. We have area trapezium is the displacement. So instead of A, we can write it as S. S is equal to half into T into 2U plus AT. Half into T into 2U plus AT. By cancelling bracket, we have half into t into 2u plus half into t into a2. By cancelling 2 and 2, we have tu plus half into a into t square. That is s is equal to ut plus half at square. This is the second equation of motion. S is equal to ut plus half at square. We have derived first and second equation from the velocity time graph. Now let us derive third equation of motion. That is v square is equal to u square plus 2as from this graph. This equation shows the position velocity relation. From the given graph, the displacement is equal to the area of the trapezium PQRS. You have already studied that displacement of a velocity time graph is the area below the graph. This portion is a trapezium. So area of this trapezium PQRS will be the displacement. So displacement S is the area of trapezium. Area of trapezium PQRS. That is half into h into a plus b. Half into h. As far as our graph is concerned, h is the time interval SR and a PS, b QR. That is half into SR is t. PS we have already learned, it is initial velocity u, and QR final velocity v. We have the equation for acceleration. Acceleration a is equal to v minus u by t. A is equal to v minus u by t. From this equation, we have t is equal to, or at is equal to v minus u, or t is equal to v minus u by a. By substituting the value of t in our earlier equation, we have s equal to half into t into u plus v. By substituting the value of t in this equation, we have s equal to half into v minus u by a into u plus v. That is half into v minus u by a into v plus u, or half a into v minus u into v plus u. You have already studied a plus b into a minus b. A plus b into a minus b is equal to a square minus b square. Similarly, v plus u into v minus u is equal to v square minus u square. S is equal to 1 by 2a into v square minus u square, or 2as. By cross multiplying, 2as is equal to v square minus u square, or 2as plus u square is equal to v square. That is, v square is equal to u square plus 2as. This is our third equation of motion.